Now, yesterday we talked about how can we compute the limits algebraically. We talked also how we find the limits of the polynomial function and also of the rational functions. And we say that for the rational functions or for any limit, just evaluate the value of x. If the value of x is defined, it will be easy. I can find the limits of any rational function. But this method is not working for the rational functions in which the limit of the denominator is 0. If the denominator here is 0, it cannot be worked. Now, and we said also we have to and we have also two cases. The first case with the denominator is 0 and and the numerator is not 0, we can find the answer and the answer will be 0. And the second case when the numerator is not 0 and the denominator also is not 0, we have to simplify and it will be infinity. And we say like this example here, the denominator is defined as an example, just you evaluate the answer and you find that how is the limit in x approaches to x. But if the denominator here is not defined, we deal with A, we say that for A here, we say that we solve it as x minus 3 times x minus 3 over x minus 3. Then, here now, I can cancel them. So it will be only limit x minus 3 when x approaches to 3. Then after that, here, we say, so it comes like polynomial. So for this type of limit, here, we have a polynomial or a function over function. But the polynomial here up, it will be equal to, yes, did you hear me?
Yes. Yes, teacher.
Okay. So when limits, both of them are multiplied and I can simplify it later on, I will have only limit x minus 3. It comes like polynomial. So it will easy for me, just I evaluate 3 and the answer is 0. So if you try it from here, you have, and for this one, it will be here 0 minus 6, 0 plus 9. So it will be a number over 0. So there's a problem. I just solve it by this way. If you say it, and also we go to B, for B, we have limit 2x plus 8 over x squared plus x minus 12 when x approaches to negative 4. And we say that if you look at the denominator here, what are the zeros of the denominator? If you simplify it, it will be x plus 4 times x minus 3. So one of the zeros are negative 4, which is approaches to it. So because of that, I have to simplify. Okay, if it's not if the denominator or the zeros of the denominator is not where x approaches to, I can just evaluate the rational and there's no problem with me. But the problem is if the zeros of the denominator is as the same as the value where x approaches to. So I have to simplify. I say this is 2 times x plus 4 over 2 over x plus 4 times x minus 3. Then after simplifying, I have now limit 2 over x minus 3 when x approaches to negative 4. And then after that, it comes like a rational function. Because here the zeros is a 3, it's not negative 4. So I just evaluate the answer and it was 2 over negative 7. And also, we talked about
Teacher?
Yes.
Can you solve the last step again?
Okay. Now, here we have 2x plus 8 over x squared plus x minus 12. This one, is this a rational or polynomial function? It is a rational. So because it's a rational, I have to check the denominator. Hey. I check the denominator. If the zeros I'm sorry, back. So here, we talked about B. In B here, is it a rational function? And because it's a rational function, I have to check the denominator. Every time when you see any rational function, you have to check the denominator. Now, each denominator, it has a zero. If the zero of the denominator is the same as where x approaches to, I have to take action. Simplify the function. If the zero of the denominator is not as the same as where x approaches to a, I will evaluate and continue. It will be easy for me. So here now, you have limit 2x plus 8 over x squared plus x minus 12. Just look at this rational function. 2 times negative 4 is negative 8, plus 8, 0. Negative 4 squared, 16, plus negative 4 or minus 4, plus minus 12, and so the answer is 0 over 0. When it is 0 over 0, I have a problem. What we have to do now? We have to simplify the function. Let's simplify it here. Just take 2 as a common factor. So it will be x plus 4 over x minus, x plus 4 times x minus 3 when x approaches to 4 or to negative 4. Then here, after that, we simplify it because we say that if we have a zeros, that approaches when x equal to a. So the first step, try to simplify or factorize them. Find the common factor and divide each numerator and denominator by what? By the common divisor. Find x plus 4. So what did you have now? You have limit 2 over x minus 3 when x approaches to negative 4. After that, it's in the first, in A, after I simplify it, it comes as polynomial. But here it is still a rational function. I simplify it and it is still a rational function. Okay, I will go back. I have to check the zeros of the denominator. What is the zeros of the denominator here? It's a 3. Is it 3 as the same as negative 4? Is it 3 is equal to negative 4? No. So I just now evaluate. Let's evaluate here. We have 2 over negative 4 minus 3, and the answer is 2 over negative 7. This is now for B. Is it clear now, Tala?
Yes, teacher. Thank you.
You are welcome. Now let's go to C. And C here, we have limit x squared minus 3x minus 10 over x squared minus 10x plus 25 when x approaches to 5. What did we have? We have a rational function. Let's try, or let's now find the zeros of the denominator. What are the zeros of the denominator? It's x minus 5 times x minus 5. Is the 5 here is 1 or where x approaches to? Yes. So I need now to simplify. X minus 5 times x plus 3. After now I simplify them. So they have a zeros. Simplify. Let's simplify. What did we have now? We have now limit x plus 3 over x minus 5 when x approaches to 5. What did we have? Did we have a polynomial and evaluate? No, we have a rational, like the previous one. But since we have a rational, as I told you, every time you have a rational, yes?
Isn't it x plus 2? The numerator.
Ah, yes, thank you.
You're welcome.
Now, so after that here, I will look at where now? I will look at the zeros of my new rational function. What is the zeros here? It is 5. It is still 5, like where x approaches 2. So what did I do? I have now to check the limits into the positive, into 5 from the right or 5 from the left. Let's check now limit x plus 2 over x minus 5 when x approaches to 5, and also here, at here you say 5 from the right. And here now, limit x plus 2 over x minus 5 when x approaches to 5, but from where now? From the left. It's okay? Here, I mean like you try, and you have to try as much as you can to find a value of the limit. If it is polynomial, I can't find a value. If it is number or 0 over number, it's easy for me. I can find the value. But if it's have like a, I try to simplify. I must try to find a value for it. For a, after I simplify, I find the value. For b, I find the value. For c here, after I simplify it, I cannot find the value. So what I have to do, I want to continue now and try also to find the value. Okay, I said, okay, after I simplifying it, there's also a problem. I want to see also if there's a value from the right and from the left. Let's now find it from the right and from the left. I will take the space here. So limit.
Miss Nima,
Yes.
sorry for interrupting. Shahad is waiting in the lobby.
I cannot accept her because if I will go back, back. Everything will clear. Wait a minute, and I will later on accept her. So limit. What was limit? It's x plus 2 over x minus 5 when x approaches 5 from the right. So here, let's put 5. I'm talking about 5 from the right. So I'm talking about this area here, where x here and all the numbers are greater than 5. Let's try now number 6 or 7 or 10. Any number, it must, in my this number, it must be greater than 5. So limit, choose number 7 as an example. Let's choose limit 7 plus 2 over 7 minus 5 is 9 over 2. Does the final answer positive or negative? It is positive. Since it's positive, I told him, finally, I find a value for the limit, and it was positive infinity.
Teacher?
Yes?
Teacher, can you write with another color because red hurts my eyes?
Okay. So, because now After evaluate number 7 here, we found that finally I find the answer. I didn't tell him no, I have to check. I find the answer. It is positive infinity. And then I will try now with limit x plus 2 over x minus 5. But now when it is 5 from the left. Here. Try number 2 as an example. 2 plus 2 is 4. Evaluate in the rational function. Over 2 minus 5 is negative 3. So 4 over negative 3. What is the value here? Is it negative or positive? It's a negative. So finally, I find a negative infinity for it. Then after that, we know that if we have check the limits from two-sided, I have to check that if they are equal or no. So is the limit from x approaches to 5 from the right is equal to the limit when x approaches 5 from the left? Here we have positive infinity. It's not equal to negative infinity, so I say it's not defined. Let's now go and accept الشهد. Then back. So here I must find a value for the limit. If it is, if it is rational, I have to check what the zeros of the denominator. If the zero is not as the same as where x approaches to a, so I continue and I evaluate the answer. It's just easy. And finally, I find a number. But if the zero here is not equal, if the zero here is equal to x, where x approaches to a, is equal to a, what did I have to do now? I have to simplify. After we simplify, as we say in A, after we simplify, sometimes I just have a polynomial function. If I have a polynomial, you can evaluate. Sometimes after I simplify, I find also a rational function. For this rational function now, I have go and repeat my 3, you can name it. I will have now to repeat it also. Because we have a rational, I have to check the zeros. If the zeros now, so I go back and repeat from here. If the zeros now is the zeros of the denominator, as we say in B, is the same as, or is not as the same as x approaches to a, you have to evaluate. So if that's not equal when x approaches to a, you can evaluate. But when it's equal, I cannot simplify because it is the most simplified one. Because it's not, because I cannot simplify, I have to check it when it is go to a from the right and a from the left. I want to try to do, what can I do? Even to find a value. It could be a number, or it could be positive or negative infinity. After I finished here, I will stop. Then I will check. It could be defined or undefined. Let's now solve number 9 here. Number 9, I think we solved yesterday. Let's do now number 10. But I solved the previous one just to memorize and just to be sure that you understand. Now let's do a limit. Limit x squared minus 4x plus 4 over x squared plus x minus 6 when x approaches to 2. Now by here, let's now look at the zeros of the denominator. It is x minus 3. I'm sorry, x plus 3 times x minus 2. So what are the zeros of the denominator? Negative 3 and 2. Are one of them is equal to a? Yes. So I cannot evaluate. I have to simplify. Let's go back here. X minus 2 times x minus 2. So as you see here x is out, the 0 is as the same as a. So you have to do it now to simplify. After you simplify, you will get limit x minus 2 over x plus 3 when x approaches to 2. Let's now, what did you have now? We also have a rational function. We have a rational function. Let's check the zeros of the denominator. What is the zero of the denominator here? It's negative 3. Is it the same as 2? No. So what did you have now? You have to evaluate. Just say 2 minus 2 over 5, which is 0 over 5, and 0 over 5. There's no problem with it. The answer is 0. So finally, I find a number or a value for the limit. Let's now do number 15. In number 15 here, he asked you find the limit of x over x minus 3 when x approaches to 3 from the right. He told me that I simplify it. I give you the most simplest function. I want you now to tell me that I know that's not undefined. Cannot be defined because the zeros of the function here, which is a 3, it is as the same as a. And I gave you the most simplified one. Yeah, he put me here. I have now to do what? To check it's from the left and from the right. Let's do now put number 3 here. Let's take 3 from the left as he asked me to do. Take number 4. 4 over 1 is positive value. So I will tell him here now that the answer here is positive infinity. Then number 16, he asked me now to do limit when x approaches to 3 from the left. He asked me here now. Choose number 2 as an example. 2 over 2 minus 3, it's 2 over negative 1, so it's a negative value. So the answer is negative infinity. In number 17 now, he asked me to find limit of x over x minus 3, which is that one, but when x goes to 3 from the 3. And we said before, if he asked me to find it from 3, I have to find it from limit when x approaches to 3 from the right and limit when x approaches to 3 from the left. From the right, it is positive infinity, as we said. And from the left, it's also negative infinity. Is positive infinity is equal to negative infinity?
No.
No? Sorry.
Yes.
Yes?
Miss, can I take negative numbers? Like negative 1, negative 2.
Yes.
طيب أنا
You can.
جربت أخذ negative 4 طلع معي الأنسر positive.
Negative 4. It's negative 4 over negative 4 minus 7. Yes, but I think you have to choose numbers near to 3. And here, to choose numbers near to it.
Okay.
Okay?
Okay. Thank you.
Okay, now you're welcome. So here you have positive and negative infinity. So I will say that it's not. Sorry, what happened here? You say I cannot write. Just say that it's not defined. Now
teacher.
Yes.
التيتشر سأل هشام إن اللابتوب بتاعها فصل فرجعت تاني يعني in the lobby.
Yes, I accept that. شهد هشام.
يس تيتشر دخلت خلاص شكرا.
خلاص. يلا. شهد وميهاد وأنا إحنا أصدقاء من مسا كمان مع أولاد صغار. طيب يلا. Now number 18. In 18 here, you want to check limit x over x squared minus 4 when x goes to 2 from the right, and also limit when x goes 2 from the left, and also limit x when x goes to 2 for x over x squared minus 4. Look here now. Limit x over x squared minus 4. Take 2 from the right. So let's now try number 3. 3 over 9 minus 4 is 5, so it is a positive value. So I will tell him that it is positive infinity. Now let's choose 2 from the left. As an example, choose 0. 0 over, oh no, not 0, 0, we're gonna try 1. 1 over 1 minus 4 is negative value. So the answer now is negative infinity. Now limit x when x approaches to 2. I have to check when limit x goes 2 from the right and limit x when it is go 2 from the left. From the right it is positive infinity, and from the left it is negative infinity. So I will tell him that it's the limit is n not existed. Now let's do here. I think it's the same idea. Yes. Y plus 6. No. Let's see here. Limit y plus 6 over y minus 6 times y plus 6. If you try it now to simplify them, you will have limit over. So here I can simplify. After I simplify, I have 1 minus 6. But since also we have a rational function, so I have to check the zeros of the denominator. Is the zeros of the denominator as the same as a? Yes. So let's find now the limit of it from the left and then from the right. From the left, take number 7. 1 over 7 minus 6 is 1. So the answer is positive. So it is positive infinity. 1 over y minus 6 like number 5. 1 over negative 1, it's negative infinity. So I will tell him that limit 1 or y plus x over y squared minus 36 when y approaches to 6. Since they are not equal, so I will tell him it's not existed. Now let's have another example. Limit x raised to the power 4 minus 1 over x minus 1 when x approaches to 1. As we see here now, it is a rational function, and the zeros of this rational function, which is 1, is equal to a. So, as we said, I'm sorry, it was clear. We have to simplify. So let's simplify to x squared minus 1 times x squared plus 1 over x minus 1. Then this one, which is x squared minus 1, I can also simplify it to be as limit x minus 1 times x plus 1 times x squared plus 1 over x minus 1 when x approaches to 1. Then, after you simplify, you will find that the answer is limit x plus 1 times x squared plus 1 when x approaches to 1. What will happen with me? It comes a polynomial. So there's no problem with me. Just you have to evaluate the number, which is 1 plus 1 here times 1 plus 1, 2 times 2, and the answer is 4. Here, it is irrational. Simplify it. After I simplify, I get a limits of polynomial function. So it just now it comes as easy for me. I have to evaluate. Let's do now another. Another example now. Limit 6x plus minus 9 over x cubed minus 12x plus 3 when x approaches to 0. The first step here, what are the values of it? Here, what is the zeros? X cubed minus 12x plus 3. If it will be any number, but the x it will be not from its zeros. Let's try now to evaluate the limit. Here, 6 times 0 minus 9 over 0 minus 12 minus 0 plus 3. So what is the answer? 0 minus 9 is negative 9 over 3. So the answer is negative 3. So it is irrational and it has a value, which is negative 3 without simplifying. Let's do now also limit of t cubed plus 8 over t plus 2 when t approaches to negative 2. Look at the zeros of the function of the denominator. Is it negative 2, which is as the same as a? Yes. So I have now to simplify. I will say. Now, you know before that if you have a cubed plus b cubed, I can simplify it as a plus b times a plus ab or squared plus ab plus b squared. This is if I have a cubed plus b cubed. Here also I have t cubed plus 8. I can simplify it as a cubed plus b cubed. It will be a plus b. What are the cubic root of t? It's t. And of 8, it's 2. Then t squared plus ab or 2ab. I can remember now. Plus 2ab is 2 times 2 times t plus b squared, which is 4, over t plus 2 when t approaches to negative 2. Then here we have, I can cancel them. So it will be now t squared plus 4t plus 4 when t approaches to negative 2. Let's now evaluate it because we have now a polynomial function. That's easy for me. So let's now evaluate it. Negative 2 squared, it is 4, plus 4 times negative 2, it's negative 8, plus 4. 4 plus 4, 8 minus 8, the answer is 0. Is it clear?
Yes, miss.
Do you have any question?
No.
Okay. Okay, I will stop here today. Inshallah, on Sunday, we will talk about limits involving radicals. How can we find the limits for them, and how can we simplify in order if we have the denominator is 0. Thank you for listening. Have a nice weekend.
Thank you.
Thank you.
Thank you.
Good teacher. Bye.